to make the glucose molecule reactive. Otherwise, a reaction will not be proceeded. So this is a common concept. Whenever a reaction is going to take place, the substrate molecule first to be prepared for the reaction. And in chemistry, you have been told that some sort of activation energy is required to make the molecule reactive. And of course, this energy is responsible, even if the molecule is ready for the reaction, but still we need some energy as activation energy to make the molecule more reactive. So initially, we need some energy. And that's why we say energy investment phase, because you are going to to invest some sort of energy. You cannot earn anything without investment. So the first stage, we are going to use or to consume some sort of energy for the process of glycolysis. Now, what's going on in this stage? Glucose or hexose sugar, same thing. Glucose being and hexose being 6-carbon sugar, so glucose has 6 carbon, is therefore need to be phosphorylated. I told you what is meant by phosphorylated. Whenever a phosphate group is added to any one of the molecules, we say it has been phosphorylated. So what is the magic of this phosphate group? The magic of this phosphate group, because this phosphate brings a lot of energy. It's energized phosphate because it gets detached from the ATP, adenosine triphosphate. So in the energy investment phase, we remove a phosphate group, and that phosphate group should be added on the sugar molecule to make it active. So means glucose should be phosphorylated for its activeness. Now, initially, 2 ATPs are required to double phosphorylate hexose sugar into 2 different reactions. You know, ATP is the energy currency, and that is the molecule, the only source of energy that can be provided for body metabolism. So since this reaction is exothermic, I mean require energy, I mean to make the glucose molecule active, so 1 ATP is not sufficient as an activation energy source. We need at least 2 ATP molecules to make the glucose molecule active. So double phosphorylate means 1 phosphate should be added to sugar, and then another phosphate is also added to sugar. But in this stage, you have to break 2 ATPs, because 1 phosphate from 1 ATP and the other phosphate from the second ATP. Now, the resulting molecule is therefore called hexose bisphosphate. Bisphosphate means diphosphate. I mean, hexose means sugar, glucose, and bisphosphate means 2 phosphate groups. So you have added 2 phosphate groups on the hexose sugar to make it reactive. So this is the most important thing in the energy investment phase, that you have to add 2 phosphate groups on the sugar molecule. So therefore, 2 ATP molecules have been invested. Sugar is not only phosphorylated, but also isomerized. You know, isomer means in chemistry, you have been told that if a compound have different structural formula, then it is the isomer. I mean, if there are 2 molecules, both have the same molecular formula, both have the same number of elements, they both have the same number of atoms as well, but their bond angles are different, their structural formula is different, and they're called isomer. So keep in mind here that when you are going to make some molecule isomer, I mean to bring certain changes in its bond angle, this also makes the molecule more reactive. So the most important thing up till now you got that whenever you want to make a molecule more reactive, you have to do 2 things. Number 1, you can make it phosphorylate by adding a phosphate group. And number 2, you can bring certain changes in its bond angle to make it as isomer. So isomer may be more reactive than the original form. Now it's called that the glucose, the sugar molecule is isomerized to fructose. Here is fructose, and here is sugar means here glucose. Although fructose is also sugar, but this sugar represents glucose. So glucose is not only phosphorylated, but also isomer its structure to fructose before phosphorylation. So fructose is more reactive than glucose. Summary, fructose is more reactive than glucose. So you make the molecule more active by converting it into fructose and also phosphorylating it. Isomers have different structural formulae and therefore bring changes in their bond energies to make itself more unstable in this case. Unstable means more reactive. If a molecule is unstable, then it means it is more reactive. It is ready for the reaction. Otherwise, it is unstable. If a molecule is stable, then it doesn't need to bring a reaction. So unstable molecules means more reactive. Such reactions are catalyzed by the enzyme as well, which is called isomerase. So in this reaction, enzymes play important role to bring the process of isomerization called isomerase. Right. Now, in the energy investment phase, we have to bring the more detail now. First step, a phosphate group is transferred from ATP to glucose, making glucose 6-phosphate. Now, what does this statement mean? A phosphate group is transferred from ATP to glucose, making glucose 6-phosphate. Junaid, you here? Switch on your mic, please. Yes, Junaid here.
Yes, sir.
Junaid, can you tell me how many phosphate group have been added to this glucose? Look at the name. To making glucose 6-phosphate.
One phosphate group.
Then why it says 6-phosphate?
Because the phosphate group is attached on the sixth carbon.
Excellent. That's what I'm asking you. Phosphate group, which is attached on carbon. So some of the students they confuse it. They say, what do you mean by 6-phosphate? It means that the phosphate group has been added to 6th carbon in the sugar, and that is glucose 6-phosphate. All right. Let's see the next reaction. Now, the glucose 6-phosphate is more reactive than glucose because it has been phosphorylated. And the addition of the phosphate also traps glucose inside the cell, since glucose with a phosphate can't readily cross the membrane. So there's a lot of things in this statement. And most, if you see your past papers, there's questions of 2 marks for this reaction. What is the benefit of this reaction? It means glucose 6-phosphate is more reactive. So for 1 mark, you can just say that glucose is we add phosphate group on the glucose to make it more reactive. This is 1 mark. What are the other mark? You can say that the plasma membrane of the cell have protein channels because glucose is a polar molecule. Therefore, there are protein channels for the glucose molecule. So glucose molecule will facilitatively diffuse from the tissue fluid inside the cell through these channels. Now the problem is here that this channel allow glucose in direction depending on the concentration. If there is more glucose inside the cell, then glucose will flow from the cell into the tissue fluid. But if there is less glucose in the cell and more in the tissue fluid, then they will move from the tissue fluid. Now, since glucose is constantly entering the cell, now there is a risk that if there is more glucose inside the cell, they will start move back in the cytoplasm. So to prevent the backflow, once the glucose enters the cytoplasm, a phosphate group is immediately added to it to make it as glucose 6-phosphate. Now this glucose 6-phosphate cannot cross this protein channel back from the plasma membrane. It means glucose will be trapped inside the cell. I mean, if it were in the same form like glucose, there's a risk that glucose can move back from the cell. But in this case, glucose enters the cell, immediately converted to glucose 6-phosphate, Now, there is no channel in the plasma membrane of the cell for glucose 6 phosphate. So, glucose phosphate cannot move back outside the cell, it will remain trapped. As a result, indirectly, we are decreasing the concentration of glucose inside the cell and prevent it from accumulation. Because once glucose enter, immediately finish, that is, it's converted into glucose 6 phosphate. That's why cell have still demand of glucose because there's a deficiency of glucose inside. So that's why glucose will continuously remain inside the cells following the concentration gradient. Hopefully, are you getting if Josefa, are you getting this statement of second equation?
Yes, sir, clear.
Okay. So now let's move to the next point now. Now, step two. So this is this was step one, and this is the importance of step two. Oh, sorry, importance of step one. Now, step two. Now, glucose 6 phosphate is converted into its isomer, as I told you initially, fructose 6 phosphate. So there's no difference in the formula of glucose 6 phosphate and fructose 6 phosphate. The only difference is that in the bond angles. So bond angles make the fructose molecule more reactive as compared to glucose 6 phosphate. So this is the step two of the glycolysis. Now in step three, a phosphate group is transferred from ATP to fructose 6 phosphate, producing fructose 1,6 bisphosphate. Now, this step is catalyzed by the enzyme phosphofructokinase. It's not necessary to keep the name of this enzyme in mind, but just for your for your interest, I mentioned the name phosphofructokinase. But sometimes it says importance later on in the next chapter. Phosphate group is transferred. There's another phosphorylation of fructose 6 phosphate producing fructose 1,6 phosphate. So, Lubaba here, is Lubaba there?
Yes, sir.
Lubaba, I have a question. Look at in step three. Can you tell me in step three which molecule is phosphorylated and which molecule is dephosphorylated?
Fructose is phosphorylated and ATP is dephosphorylated.
Excellent. Can you tell me which reaction is exergonic and which reaction is endergonic in step three?
In step 3.
Yep.
Hydrolysis of ATP is exergonic, while when fructose gains phosphate, it's endergonic reaction.
Excellent. True. So that's why we are coupled these two reactions. The exergonic reaction is coupled with the endergonic reactions. So that's the reason we say that ATP is also like an intermediate molecule. So it means the reactions are coupled by the ATP molecule. One is exergonic and one is endergonic. Right. Let's see the next step now. Look at this reactions for a while. This is all about the in the energy investment phase, but it's very short and briefly have been given. Hence, glucose is converted to,
Can you show the previous slide once?
okay. Fine.
सर नहीं, इसके बाद जो स्टेप्स वाली स्लाइड थी उसकी बात कर रहा हूँ.
One.
यस सर, ठीक है, थैंक यू.
Now let's be to next step. Let's see these reactions for a while. Students, आप सबको मेरी आवाज आ रही है ना?
Yes, sir.
Okay. Now look and see the glucose is glucose is converted into fructose phosphate when ATP molecule has been dephosphorylated, and this fructose based phosphate, you know, we just eliminated one step. We didn't mention about the isomerase enzyme. We just converted into fructose for your simplicity. But the most important thing is that a molecule have been dephosphorylated. So two ATP molecule. The first ATP makes it as fructose phosphate or 6-phosphate, 6-carbon compound. And then another ATP is added, so that means fructose bisphosphate or fructose simon. This is called phosphorylation. Phosphorylation of what? Phosphorylation of sugar. Because on sugar we are going to add phosphate group, but dephosphorylation of ATP have been taken place. All right. Now we'll discuss about the energy. Oh, sorry, the same step, but like in some more detail. Look at the first reaction that we have discussed. Glucose plus ATP react together to make us glucose 6-phosphate and 1 ADP molecule has been released because ATP has been dephosphorylated in the first step. Now, this glucose 6-phosphate is again converted into its isomeric form, but nothing is added in this reaction. Just change the bond angle. So glucose 6-phosphate is converted into fructose 6-phosphate. Right. And then in the next reaction we have done, fructose 6-phosphate is converted. Oops, here is you must have to add 1 ATP molecule. Let me to add 1 ATP molecule here, here. So this in this reaction you have to add plus ATP as well. So that it should be right, right. Fructose 6-phosphate is further phosphorylated. I mean, one more ATP has been used to convert it into fructose 1,6-phosphate, and the ATP molecule has been released. So this is called double phosphorylation of the sugar molecule in the energy investment phase. So this is the energy investment. Any question about the energy investment phase? Students, do you have in your mind? You can ask me now. Okay, no problem. Right.
No, sir.
Okay, so let's move now. Now here, just going to make it a slideshow as well because it's very important to see. And, right. Let's discuss. Slideshow. Right. Right. Now the second phase of glycolysis is going to start after the energy investment phase. Now is the stage where sugar is going to be cleaved. So sugar cleavage is the next phase of glycolysis. So how many reactions we have discussed in the energy investment phase? 3. In one, glucose is phosphorylated. In the one is the isomerase, and in the third is again phosphorylated to make. So, Doa, can you tell me what is the substrate of sugar cleavage process? First reaction में हमारा substrate क्या? Yes, glucose. Only glucose? Sugar cleavage. No, what was the product of energy investment phase?
Product was
Energy.
energy investment means one. Hexose bisphosphate.
Yes. So you can say that the substrate of sugar cleavage is now glucose, fructose bisphosphate. Fructose bisphosphate, two phosphate groups are there. So that's why we say fructose 1,6 means two phosphate there, one on carbon number 1 and the other one on carbon number 6 of the fructose molecule. So we say fructose 1,6 bisphosphate splits to form two 3-carbon sugar called glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate. So phosphoglyceraldehyde. How many carbon we have in glyceraldehyde 3-phosphate? Doa.
Sir, can you repeat the question?
How many carbon we have in glyceraldehyde 3-phosphate molecule?
3.
3. And how many in fructose bisphosphate?
6.
So it means when hexose bisphosphate has been broken down, two molecules will be formed of glyceraldehyde because one glyceraldehyde contains 3 carbon. So therefore, two molecules of glyceraldehyde 3-phosphate will be formed. That's the statement says fructose 1,6 bisphosphate splits टूटता है to form two what? 3-carbon sugar, glyceraldehyde 3-phosphate. Now, which functional group it contains? Aldehyde. You can see glyceraldehyde means it's like a aldehyde. So this sugar contains the aldehyde group. Keep in mind. Right? Any question? Any question? No, sir. Okay. Then let's see the next one. Step 5. Now what is going in step 5? Two half reactions occurs simultaneously. Now actually in step 5 there are two reactions consecutively takes place at the same time. One reaction is phosphorylation and the other reaction is hydrogenation. Let's see. Glyceraldehyde 3-phosphate is oxidized. Now let me check your chemistry. Iman, you here?
Yes, sir.
Iman, look at this first statement in the step 5. Glyceraldehyde 3-phosphate is oxidized. If you oxidize aldehyde, then what is the product? In chemistry, I think you have been told. If aldehyde is oxidized, what will be the product?
Carboxylic acid.
Yes, good. Carboxylic acid. So, we will form the product. Oxidized means dehydrogenation. So glyceraldehyde 3-phosphate is dehydrogenated. एक और word आप यहाँ लगा सकते हैं. Oxidized की जगह पे dehydrogenated. So once the hydrogen has been removed from glyceraldehyde, this hydrogen has been captured by the NAD, as I told you initially. So NAD is reduced to NADH. This hydrogen is removed from aldehyde. And the overall reaction is exergonic. The reaction is, because oxidation I told you is exergonic reaction. Energy is released, releasing energy, and that is then used to phosphorylate the glucose, to phosphorylate the molecule, forming 1,3 biphosphoglycerate. ईमान ये बता दो, phosphoglycerate क्या चीज है? Phosphoglycerate. I mean, phosphoglycerate क्या है? Aldehyde है या carboxylic acid है? Yes? Iman, you here?
Sir, it has been oxidized, so isn't it carboxylic acid?
Yeah, and glycerate means glyceric acid. Glycerate means glyceric acid. I mean, it is a carboxylic acid. जैसे अगर आप कहते हैं oxalate, oxalic acid. fumarate, fumaric acid. So all these are the examples of the carboxylic acid, but they're in the radical form. That's why we say glycerate, isn't it? So
Yes, sir.
phosphoglyceric, you can also use the word phosphoglyceric acid. Doesn't matter. Phosphoglyceric, phosphoglycerate, or phosphoglyceric acid. But one thing more, forming 1,3 biphosphoglycerate. क्या मुझे आप यहाँ बता सकते हैं कि do you think other than addition of hydrogen, which other molecule is also added?
The ATP.
Phosphate is added, you know. Phosphate is added to the,
Yeah, phosphate. Sorry.
and this phosphate comes from the substrate and not from the ATP. Do the correction. This is the only unique case in respiration that sometime a phosphate group directly arrives from the substrate, not from the ATP. And that's why it is called substrate level phosphorylation. Now the question in our mind, do this phosphate have the same energy as like in the ATP one? No. So where the energy comes? Look this reaction. The overall reaction is exergonic, releasing energy. This energy is used to provide a phosphate group to the oxidized aldehyde to convert it into phosphoglycerate as well, and also make it phosphorylated. So two things are occurring simultaneously. Number one, the aldehyde is oxidized. Three things, not two, three. Number one, glycerate is oxidized. Aldehyde is oxidized to glycerate. एक होगी. दूसरा, its hydrogen has been added to NAD to make it NADH. दो चीजें हो गई. तीसरी चीज, in the reaction energy is released, and that energy is used to add phosphate group to the phosphoglyceric acid, and this phosphate is from the substrate which require energy. That energy is provided by this exergonic reaction. So this is somewhat complex chemistry. Keep in mind. I will also explain the simplified form of glycolysis, very simplified form. But I want to explain the exact mechanism and the depth and the details that can you handle any type of questions from the past papers if you know about the detailed concept. So up till now, about this step 4 and step 5, if you have some question in your mind, Josefa, Umran, and any other student, Junaid, you can ask me.
Sir, step 5 का second part. Can you repeat that, please?
Just ask the second part. What is the area of confusion?
Sir, the part of the biphosphoglycerate part.
We just simply, glyceraldehyde has been oxidized. Oxidized means we have removed hydrogen from glyceraldehyde. Once the hydrogen has been removed from glyceraldehyde, it had been converted to phosphoglycerate. You can see here. When hydrogen has been removed, glyceraldehyde is converted to glycerate. But there's only one phosphate was initially attached to glyceraldehyde. But when it is changed into glycerate, another phosphate is added because it's bisphosphate. So not only oxidized, but also added a phosphate group. And oxidized means we removed hydrogen. This hydrogen has been added to NAD plus and converted into NADH. The overall reaction is exothermic, releasing energy, and that energy is used to attach phosphate to phosphoglycerate. Means 1,3-bisphosphoglycerate. So two phosphate groups have been added to a sugar molecule, and now it's in the form of 1,3-biphosphoglycerate. Clear?
Yes, sir. Clear. Thank you.
So this is about the energy investment phase as well, and we also talk about now. The next one is the energy yielding phase. Now, how will the energy should be released, and how many steps are there? So, Junaid, will you like to tell me what will be the substrate of energy yielding phase now? Yes, Junaid. Junaid here.
Yes, sir.
Yeah, Junaid.
Sir, can you please repeat?
Yes. Energy yielding phase. What will be the substrate of energy yielding phase? I mean, indirect my question, what was the product of energy glucose cleavage phase? Which will be the substrate now here?
Sir, the oxidized form of glucose.
You know about the name of that molecule? Phosphoglyceric
Yes,
acid.
sir.
I told you.
Yes.
1,3 by 1,3 bisphosphoglycerate. 1,3 bisphosphoglycerate.
Glycerate.
अगर आपको phosphoglycerate प्रोनाउंसिएट करने में प्रॉब्लम हो तो आप सीधा सीधा कह सकते हैं PGAL phosphoglyceraldehyde. PGAL यानी पागल. PGAL phosphoglyceraldehyde. ये इनिशियल फॉर्म के लिए होता है और फॉस्फोग्लिसरिक एसिड को कहोगे PGA फॉस्फोग्लिसरिक एसिड PGA, या इसको आप गैलिसरेट फॉस्फेट भी कह सकते हैं GP गैलिसरेट फॉस्फेट. ऑल दीज नेम्स आर एक्सेप्टेबल इन CI. सो अब हम कहते हैं कि हमारा जो प्रोडक्ट है इन द एनर्जी क्लीवेज फेज दैट वाज द 1,3 biphosphoglycerate. How many molecule of 1,3 bisphospoglycerate we have? Iman, how many molecule of 1,3 bisphosphoglyceric acid we have?
The one.
How many carbon it has?
3.
So then how can you say 1? Because we have extracted from glucose and glucose has 6 carbon. So we have 2 molecule of 1,3 bisphosphoglycerate. Right?
Yes, sir.
Okay. Now I will tell you about what is going on with one molecule, and you have to double then multiply by 2. So if one molecule produce the same thing, the other also with the same root. You just have to multiply with 2. Step 6. Now 1,3 bisphosphoglycerate donates one of its phosphate group to ADP, making a molecule of ATP and turning into 3-phosphoglycerate in the process. So by congratulations, we got the first ATP molecule here. हमने पहली ATP बनाई. और कैसे बनाई? How many phosphate were there with phosphoglycerate? 2. एक कार्बन नंबर 1 पे और एक कार्बन नंबर 3 पे. ये 3 कार्बन कंपाउंड था. Now इन्होंने एक phosphate को donate किया और ADP को दिया, and this ADP has been converted to ATP, the first molecule, and turned it into 3-phosphoglycerate in the process. So how many ADP we got now? How many ATP we got now?
1 ATP.
Overall 2 ATP. Because this is from one
So we
molecule.
got 1 ATP.
Yeah, this is 1 ATP, but this 1 ATP is from 1,3 bisphosphoglycerate, and we have 2 molecule of 1,3 bisphosphoglycerate. And I told you that you have to multiply by 2. So up till now we got 2 ATP, not 1. Got it? Dua, got it? We got 2 ATP, not 1, beta. This is from 1 molecule of 1,3 biphosphoglycerate. Right? Okay, it's Zoom time is going to over now. I'm just going to connect it again, please. So stay with me.